There's a form of energy that produces almost zero carbon emissions, generates more power per gram of fuel than anything else on the planet, runs 24 hours a day regardless of weather, and has killed fewer people per unit of energy than coal, oil, gas, and even solar. Most countries refuse to build it. Some are actively shutting it down. And the reason is almost entirely because people misunderstand how it works. Nuclear energy might be the most unfairly feared technology in human history. And I think a lot of that fear comes from the fact that nobody ever explained it properly. They just showed you mushroom clouds and told you to be scared. If you're the person who never gets it until someone gives you the right analogy, this channel is for you. Subscribe. Let me start at the absolute bottom. Atoms. Everything around you, your chair, your phone, the air in your lungs, is made of atoms. Atoms are absurdly small. A single grain of sand contains more atoms than there are grains of sand on every beach on Earth. And every single one of those atoms has a core called the nucleus, which is where the word nuclear comes from. Now here's the part that matters. The nucleus is held together by an insane amount of energy, like an almost incomprehensible amount. Think of an atom's nucleus like a tightly compressed spring that's been welded shut. Under normal conditions, the spring stays locked. It just sits there, stable, quiet, harmless. But if you manage to crack it open, all the energy that was holding it compressed gets released at once. That's nuclear energy. You're not creating energy from nothing. You're releasing energy that was already locked inside matter. Energy that has been sitting there since the atom was formed billions of years ago. 1 kilogram of uranium fuel contains roughly the same amount of energy as 14,000 kilograms of coal. Same weight as a bag of flour versus 3 fully loaded dump trucks. That's not an exaggeration, that's actual math. The energy density of nuclear fuel is almost absurd compared to anything else humans have access to. So how do we actually crack those springs open? The process is called fission, and it works like dominoes. Imagine a room absolutely packed with mousetraps, each one loaded with a ping pong ball sitting on the trigger. Now throw one extra ping pong ball into the room. It lands on a mousetrap, which snaps and launches its ball into the air. That ball comes down and triggers 2 more traps. Those 2 trigger 4. Those 4 trigger 8. Within seconds, the entire room is a blur of flying ping pong balls and snapping traps. That's a nuclear chain reaction. You start by firing a tiny particle called the neutron at a uranium atom. The uranium atom splits, releasing energy and 2 or 3 more neutrons. Those neutrons hit other uranium atoms, which split and release more neutrons, which hit more atoms. One reaction becomes 2, becomes 4, becomes millions, and the energy output is enormous. In a nuclear bomb, this chain reaction happens completely uncontrolled. Every trap in the room fires as fast as possible, and you get an explosion. In a nuclear power plant, the whole point is controlling the chain reaction, so it happens slowly, steadily, and predictably. Same physics, completely different application. And controlling it is actually simpler than people think. A nuclear reactor is basically a very expensive, very carefully designed kettle. I mean that literally. The chain reaction heats water, the hot water creates steam, the steam spins a turbine, the turbine generates electricity. That's it. The nuclear part is just the heat source. Everything after that is identical to a coal plant or a gas plant. Steam, turbine, electricity. The control happens through something called control rods. Think of control rods like the volume knob on a speaker. Push the rods deeper into the reactor, and they absorb more neutrons, which means fewer chain reactions, which means less heat. The music gets quieter. Pull them out, and more neutrons fly freely. More atoms split, more heat is generated. The music gets louder. If something goes wrong, the rods drop all the way in, and the reaction stops. Volume to 0. Modern reactors are designed so that the control rods drop automatically under gravity if power is lost. No human decision required, no computer needed. The laws of physics shut the reactor down. That's not a marketing claim, that's engineering. Quick favor before I get into the part everyone actually wants to know about, which is the danger. If this has been useful, hit the like button. Every single one helps this channel reach people who'd actually benefit from it. Back to it. Let me be honest about the risk, because pretending nuclear energy has no downsides would make me no better than the people pretending it has no upsides. The danger with nuclear energy comes down to three things: meltdowns, waste, and weapons. Let me take them one at a time. Meltdowns are what happened at Chernobyl and Fukushima. A meltdown is what happens when the chain reaction isn't controlled properly and the fuel gets so hot it literally melts through its container. Think of it like a pot on a stove with the burner stuck on high and nobody in the kitchen. The water boils off, the pot overheats, and eventually the metal starts melting. That's a meltdown. Chernobyl happened because the reactor design was fundamentally flawed and the operators deliberately disabled multiple safety systems during a test. It was a 1970s Soviet design with no containment building. Fukushima happened because a tsunami knocked out the backup power that kept the cooling water flowing. Both were terrible, both killed people, and both are the reason modern reactor designs look nothing like either of them. Modern reactors have passive safety systems, meaning they cool themselves without needing pumps or power. Some use molten salt instead of water, which can't boil off the way water can. Some are small modular reactors built underground. The analogy I'd use is comparing a 1970s car with no seatbelts, no airbags, and a steel spike for a steering column to a modern car with crumple zones, automatic braking, and 8 airbags. Both are cars. One is dramatically safer than the other. Judging modern nuclear technology by Chernobyl is like refusing to drive because a Ford Pinto exploded in 1978. Nuclear waste is the second concern, and it's the one that's hardest to dismiss quickly. When uranium fuel is used up, it's still radioactive. It needs to be stored safely for thousands of years. That sounds terrifying, and on a human timescale, it is. But here's the part that gets left out. The total volume of nuclear waste is shockingly small. All the nuclear waste the United States has ever produced in its entire history would fit on a single football field stacked about 10 yards high. Compare that to coal, which produces millions of tons of ash and carbon dioxide every year, spread across the entire atmosphere where nobody can contain it. Think of nuclear waste like a small box of extremely dangerous material locked in a vault versus coal waste like millions of tons of mildly dangerous material dumped into the air for everyone to breathe. The small box is scarier to look at. The invisible cloud is doing more actual damage. The weapons concern is real, but often overstated for civilian power. A nuclear power plant cannot explode like a nuclear bomb. The physics don't work that way. The fuel in a reactor is enriched to about 3 to 5%. A bomb needs 90% or higher. It's like comparing beer to pure ethanol. One can't become the other without a completely different industrial process that has nothing to do with power generation. The legitimate weapons concern is that countries building nuclear power infrastructure could potentially use parts of that infrastructure to enrich fuel to weapons grade. That's a real geopolitical issue, but it's a policy problem, not a physics problem. And it applies to a handful of unstable nations, not to the concept of nuclear energy itself. So why don't we build more of it? Honestly, fear, cost, and politics. The fear comes from Chernobyl and Fukushima dominating public perception for decades. The cost comes from the fact that nuclear plants take 10 to 15 years to build and billions of dollars up front, even though they run for 60 plus years and produce incredibly cheap electricity once operational. And the politics come from the fear, which makes it nearly impossible for elected officials to champion nuclear without losing votes. I think nuclear energy is one of those rare things where the public perception and the scientific reality are almost completely inverted. The thing people are most afraid of is statistically one of the safest options available. And the thing people feel safest about, burning fossil fuels because we've done it for centuries, is statistically the most dangerous by a wide margin. Let me stack all of this together so it locks in. Atoms have nuclei held together like compressed springs. Cracking them open releases the stored energy, and nuclear fuel packs roughly 14,000 times the energy of the same weight in coal. Fission works like a room full of mousetraps. One trigger sets off a chain reaction. A nuclear reactor is a kettle that uses that chain reaction to boil water, spin a turbine, and make electricity. Control rods are the volume knob. Modern reactors shut themselves down by gravity if anything goes wrong. The waste is a small locked box versus coal's invisible cloud, and a reactor can't become a bomb for the same reason beer can't become pure ethanol. That's nuclear energy. Not the mushroom cloud version, not the Hollywood version, the actual version. If this helped nuclear energy click for you, do me 2 quick favors. Hit the like button and subscribe so you catch the next one. I'm deciding between 2 topics for the next video, and I want you to pick. Should I explain how the internet physically works using a postal system analogy, or how credit scores work using a reputation system analogy? Drop A or B in the comments, and whichever gets more votes, I'll make first. Thanks for watching.